Every night, when you look up at the moon, it's saying a very slow goodbye. Right now, as you watch this video, our celestial companion is quietly slipping away from us. Not dramatically, not suddenly, but with the patience of cosmic time itself. Each year, the moon moves 3.8 centimeters farther from Earth. That's about the length of your thumb. It doesn't sound like much, does it? But this tiny annual retreat holds profound consequences for our planet's future. Welcome to the Cosmos Quest. How do we even know this is happening? The answer lies in one of the most ingenious experiments. During the Apollo missions of the 1960s and 70s, astronauts placed special mirrors on the moon's surface. These retroreflectors are still there today. Scientists bounce powerful lasers off these mirrors and measure how long it takes for the light to return to Earth. By timing this cosmic game of catch, they can calculate the moon's distance with incredible precision. The results are consistent year after year. The moon is receding from Earth at an average rate of about 3.8 centimeters per year. This measurement has been confirmed through decades of lunar laser ranging experiments. But why is this happening? The moon's gravity pulls on Earth's oceans, creating tidal bulges. But here's the interesting part. These bulges aren't perfectly aligned with the moon's position. Earth's rotation carries the tidal bulge slightly ahead of the moon. This creates a gravitational tug-of-war. The gravity of the closer tidal bulge on Earth is pulling the moon forward, which increases the size of the moon's orbit. It's like giving the moon a tiny gravitational push that speeds it up and sends it into a higher, more distant orbit. Meanwhile, this same process is gradually slowing down Earth's rotation. Our days are getting longer, but only by about 2 milliseconds per century. The energy from Earth's rotation is being transferred to the moon's orbit in this elegant cosmic dance. This process has been going on for billions of years. When the moon first formed 4.5 billion years ago, it was much, much closer to Earth. Some scientists estimate it was only about 15,000 miles away. That's 16 times closer than today. Imagine looking up at the night sky and seeing the moon filling a huge portion of it. The tides back then would have been enormous, perhaps 1,000 feet high. Days were only about 6 hours long because Earth was spinning much faster. Over geological time, the moon has been steadily retreating to its current comfortable distance of about 239,000 miles. And it's not stopping. This gradual separation has profound implications for our planet's future. One of the most striking consequences affects something many of us have witnessed: total solar eclipses. The moon currently appears almost exactly the same size as the sun in our sky, allowing us to witness total solar eclipses when the moon completely blocks the sun's disk. This perfect alignment is actually a cosmic accident. But as the moon continues drifting away, it will eventually appear too small to completely cover the sun. Total solar eclipses will end entirely in about 618 million years. Future generations will only see annular eclipses, where a ring of sunlight remains visible around the moon's edge. This change could have consequences for ocean mixing, climate regulation, and coastal ecosystems over millions of years. The tides will become weaker, potentially affecting marine life that depends on tidal patterns. This Moon-Earth relationship isn't unique in our solar system. Many moons throughout the cosmos are either spiraling inward toward their planets or outward away from them. It's a natural consequence of gravitational physics. But don't worry about losing the moon entirely, though. The process is incredibly slow. Even if the moon continues retreating at its current rate, it would take tens of billions of years to escape Earth's gravitational influence completely. The sun will likely become a red giant and engulf both Earth and Moon long before that happens. What's remarkable is that we live during a time when the moon appears exactly the right size for perfect solar eclipses. It's one of those beautiful coincidences that make our cosmic perspective so special. The next time you see the moon, remember that you're witnessing a moment in an incredibly long cosmic story. That familiar face in the sky has been slowly pulling away from us for billions of years, and it will continue long after we're gone. It reminds us of how dynamic our apparently stable solar system really is. Nothing in space is truly static. Everything is moving, changing, evolving over time scales that dwarf human experience. What amazes you most about this delicate balance between Earth and Moon? Share your thoughts in the comments below. And if this celestial revelation fascinated you, subscribe to the Cosmos Quest for more incredible stories from our universe. Until next time, keep looking up. And remember that even in the vastness of space, everything is connected in ways we're still discovering.